of all. Run all, please. Okay, don't need the map. Cells, value. Oh, yeah, area, perimeter, price. Yep, they all show up there, which is what I was hoping for. So let's take a quick look here. Yep, the R, 216, then 32, 392. All right. So yeah, I'm liking those values. So let's go ahead and instead of displaying the region, int total equals 0 for each of our region in regions. Total plus equals region dot price total. Run all 1930. Okay. Oh, that's interesting. The fact that we're constructing these objects and it feels like some objects are not persisting very well because we keep getting those blanks, except when we run everything in sequence. I think there are some downsides to using objects in this format. That is good to know. I will probably not do it again. Let's get my puzzle input though and rerun everything with that. Hang on. Collapse data. All right, the real input, full data. Whoo, big price. Correct price. All right. Fortunately, the electronic order so much fence they qualify for a bulk discount. Under the bulk discount, instead of using the perimeter to calculate the price, you need to use the number of sides each region has. Each straight section of fence counts as a side, regardless of how long it is. Oh boy. Okay, the large example has that. Okay, so we need to figure out now the sides instead of the overall perimeter. Okay. Oops, sorry. Most annoying part. I can see that. Thankfully, I feel pretty good about how my code's structured. So let's go ahead and I'm going to copy a couple of things here. I'm going to copy my definition of region. Copy cell. Paste cell. All right, and then I just also need this. Okay. Copy cell. Paste cell. Okay, so now we have the part 2. So here we have our region definition again. And now perimeter. Okay. So I want to think about how I want to calculate this. Also, before I go too far, I want to go back to working on the little data because it's much easier to visualize things with the small data set. Okay, so okay, be especially careful to count the regions like the one full of type A plants. Each section of fence has an inside and an outside, so the fence does not connect across the middle of the region. Oh, right, where the 2B regions touch diagonally. Yup. Okay. The first thing is thinking about how to sort of computationally represent this. So as we're going through our cells, basically, okay, I've got kind of a thought here, which is as we're going through the cells, we can kind of think about for every cell, there's the question of does it have left, right, top, or bottom? So like the upper left corner has a top fence and a left fence. And because of that, all right. So yeah, I mean like this gets us all of our region stuff. We process the cell. So actually hang on here. Yeah, this right, that populates our regions. And then we do this. Okay. Okay, I see a brute force way to do this. There might be a better way, but I see a way to do this with kind of a fairly straightforward representation. So what we're going to just do here is we're going to create a new tuple using fence equals coord comma, and what I also I found a collapse hotkey or some sort. Okay, using fence equals coord, and actually what we're going to say here first is enum direction equals, and we want to do this in the same order, so +1, that is +1 column. Okay, so cardinal directions, our first one there is 0 change to row, 1 change to column. So that is going to be right, left, down, up, based on which one of those we've got. 0, left equals 1, down equals 2, up equals 3. Oh, right, no equals on the definition of an enum. So there we are. Coord, direction, dir. Actually, I'm just going to say a coord C, direction D. Okay, so we now have a tuple for our fence type there. Oh, a using cause must precede everything else in the area. Is this going to work? Yes. Okay, cool. So we now have fence. So what I want to do here is, as we do the perimeter, we're going to make a small change to how this works. For every cell, we're still going to look at the cardinal directions. Except what I need to do is zip them with their thing. So, all right. For each coordinate cell in cells, we're going to say we're going to say direction dot no, or no, yeah, direction dot get. Actually, I just want to check here. Direction dot get values cannot be inferred from the usage. Oh, retrieves an array of the values of the constants in specified enumeration. I mean, okay, it's just going to be array.enum.getValue. Okay, so we're going to get the values of direction. I guess any enum can let us do that. Okay, yeah. So let's just, instead of saying direction.getValues, I'm going to say enum.getValues direction dot zip with cardinal directions and var directions equals, okay. And now what I just want to do here is quickly, we need this earlier. We need this before we start looping. All right, then display, yeah, directions. Okay. Now, nothing much is going to happen here yet. We're just going to run this because I would like to see, right, nothing invokes it. We call down here and we get, yes, right, 0, 1, left. Okay, good. So we have these zipped pairs, and that's critical. So, and in fact, the zipped pair goes, oh, coordinate direction, and this one, the zipped pair there went differently. Okay, yeah, things are basically getting knocked out of memory, it looks like, at some points. That's good to know. But okay. I'm going to go the other way, direction D, coord C, because that now means that the types of these are going to be fences. So if we come back over here, var fence direct, IEnumerable of fence directions. Yes, those are what they are. So that means we now have a set of fences. Great. So now what we want to do is, again, we're going to look at each cell. So step one is we're going to look at fence directions. So it's hash set coord neighbors. So it's actually going to be hash set of fences equals fence directions dot select c, and we're going to add c dot c, or actually we're going to do f. We're going to add f dot c to cell. All right. Oh, except that needs to transform that, right? So add f dot c to cell, comma, f dot d. Except they're in the wrong order. Okay. So now we have a set of directions there. All right. And that gives me, right, before we did something with the cardinal directions to eliminate some, yeah, we eliminated some other options here, right? So I'm going to go ahead. Oh, wait, did we do that there? No, we did that just there, right, except for the ones that are in cells. So, right, what this is going to get us is a set of potential fences with directions. And then result plus, so what we then need to do is I need to say fences equals fences except where f goes to f dot c, f goes to cells dot contains f dot c. Hash set does not contain a definition for except where, and I don't need that count. I thought I had an except where. Let's go take a quick look at hash set. C# hash set. What can I do with one of these? Because what I want to do is find, again, the same things we did before, but this time I want to get all the fences because I'm then going to do something to coalesce them. So, right, we got some hash sets. Add clear contains. No, okay, except with the elements in that thing. Oh, dot remove where. Hang on. Removes all elements. Oh, and actually that one does it. Dot remove where predicate. And this one actually is a mutating operation. So that's. Why is this unhappy with. No, needs one more parent. That's why it's unhappy with me. Okay. So now we grab all the fence directions and we remove the fences that would be between us and a cell in ourselves. And now we have this list of fences. And so the other thing we want to do here is hash set of fence. All fences is a new blank hash set. And we're going to say and if I want to add a bunch of elements here, I know there's probably a union, but no, you add one element. I thought there was a pretty quick way to add. No, dot intersect with. That's no subset, or is it dot? Oh, yeah, dot union with modifies the current hash set to there we are. So all fences dot union with fences. And now what we want to do here is return all fences dot count, but it won't be ready yet. This will be what we did before. This should get us the old perimeter. Result never gets used. That's correct. But right before we do that, I want to display all fences. Okay, so we're going to try this again now. Run all and look. Here we go. So there's our, this is us displaying, I think, all fences here. Yep, left from 0 and -1, up from, oh, that's the target that we get there. That's not quite right. Because what I want is the one that it is in that position from. Glad we looked. Okay, so right, what we actually have here is, as the fences go, we're going to select, okay. So right, the fence directions should actually not change that. So instead of, right, we have those cardinal directions. So here, instead of adding to that, what we actually want to do is we want to say fence directions dot select, or not even select. Okay, so we're going to start with fence directions. And then I'm going to just comment this line out for a moment because I want to use parts of it, but I'm going to replace it. We're going to say fence directions dot, oh, actually, hang on. Yeah, we build a new, we build a new hash set out of the fence directions, which, right. No. We are actually closer to this thing. We're going to say it's going to be, yeah, fences equals fence directions dot select, but instead of adding that, we actually are just going to take the cell. We can get back to what that thing's cardinal direction was. Okay, now we're going to say fences dot remove where f such that cells dot contains add f dot c and cardinal directions sub f dot d. So now if we do that addition where it doesn't contain a neighbor in that direction. Now we do that, so now the cells should have the direction the fence is from. Let's rerun all. Okay, something, inappropriate number of parens. That's one for letting the compiler find for us. And a semicolon is expected somewhere, right there, yep. Run all. Cannot implicitly convert type direction to int, yep, okay. Run all. And then we come back down here. Okay, so now we have left and up from 0, 0, up from 0, 1, up from 0, 2. Perfect. This is what we're looking for. So now, what we need to do, okay. Now we need to deduplicate this list. So now what we've got is we have all of the fences. We've also run out of this album, and I'm just going to start over from the second track. Because it's a good album, and I don't want to think about music right now. I want to vibe on music. Okay, so here we go. We don't want to yet have all the fences. So now, right here, deduplicate parallel fences. All right. So I have this hash set of all fences, and what I want to do is say, all right, I want to do this in such a way that, right, because they need to be in runs, because we can easily have like a dun and then a skip and then continuing on the same line, and we don't deduplicate that. So, all right. Okay. I've got to think about how I want to do this. Like the easiest way would be to make sure that we always do it in a certain order. So we only remove something if we've already checked everything in a given direction. I mean, actually that's not too bad. That's not too bad at all. So what I just want to do here is yeah. For int r equals 0, r less than height r plus plus. All right, height is capital H around here. For int c equals 0, c less than width, c plus plus. For each var d in fence direction. No, it's just in direction. Okay. Can I do that? Direction is a type. Okay. Right, in enum.getValues direction. Oh, right. Height and width can't be used in here. Fine. Int height equals map dot length. Int width equals map sub-0 dot length. Okay. There we are, just getting these things into scope. Okay, so now what we want to do is, since we know that we are working across and down, and actually, hang on. We're going to do this a little bit differently. For each var direction because this is going to go column wise. So it's going to do columns first, then rows. So for each var d in direction up and direction down, we are going to quickly walk this thing. Oh, we missed a paren. All right. Coord equals r comma c. If cells dot contains coord, because we don't need to go looking for this thing in the fences if we don't already have it. So if the cells already contains coord, there's no target type. Oh. What does var think it is there? It'll probably, yeah. Okay, so if cells contains coord, then, oh wait, now it's suddenly, oh, use the, I was wondering who was going to yell at me about that. Great. Okay. So we want to basically dedupe these, and we're going to say here, if cells contains coord, then the next question is going to be, actually, hang on, I can construct this. I don't need to look at cells. So, whoa, excuse me. Back to there. Okay. For int c. All right. fence equals, that's going to be D comma RC. That creates us the tuple that we need. Cannot complicitly invert type systems collections list direction. Okay, hang on. Rebuild, are you now? Okay, now you're correct after a quick little rebuild there. No. Cannot implicitly convert type direction int. I'm not trying to implicitly convert a direction to an int. I'm trying to construct a list of directions. Hang on. Direction D in list. Cannot convert type system list collections generic list. Okay, fine. You happy now? Oh, hang on. Here, yeah. Bridge direction D in cross. The name D does not exist in the current context. Like heck, it doesn't. Oh, well, hang on. You have to. There. Great. Variable fence assigned, but its variable is never used. All right. Since we're going up by C, we haven't yet looked at C plus 1. So what we want to say now here is if all fences dot contains neighbor, all fences dot remove fence. Actually, hang on. It also just needs to be if actually, let me see if remove can safely be run without checking it, because it's otherwise we're just testing for something that we would remove anyway. So yeah, if all fences contains the neighbor that we're looking at, we remove the fence. That'll get us all the ones that duplicate across. Then we do the same thing here. Actually, let's just call this horizontal, because there isn't really a good good symmetric word that isn't down. And yeah, horizontal are the ones up and down, and then we have, and it feels weird to have down not include down. So list direction vertical equals direction left. And while this feels weird, right, a fence on the left or right of a cell runs vertically, and a fence up or on the top or bottom of a cell runs horizontally. Okay, so now we do the same thing here. Actually, wait a second. No, I don't need to do this, because I will still always get these, even though we do the sequence. Yeah, never mind. We're only looking at